two aims today. One is to convince you if you're not being a geologist or geophysicist, you should be, and two, if you are, to actually give you some information. So feel free to attract my attention and ask questions as I proceed. I've discovered I can't see what I'm talking about, so I have to go over here. And I thought when I did this lecture, why did I choose the career was a good way to start, so that's how it goes. Why choose a career? It's varied. There's a lot. Geology goes from the study of the Earth as a whole right through to looking at where the tunnel's going. Geophysics, Earth as a whole, right through to finding an unexploded ordnance somewhere in a military site. If you like being outside, it's a good career. If you like pursuing problems, solving difficult problems, it's quite a good career. So I've been to a number of exotic locations. Antarctica, I have students who are currently in Mongolia, somewhere in South America, in the middle of nowhere in Australia. I have other students who've never left an office in Perth. They process data. I've had one student who spends 6 weeks on a vessel, 5 weeks in some exotic location, 6 weeks on a vessel, 5 weeks in an exotic location. There's a skills shortage in the area, but I'll be honest, it's a cycle. So I'm a geophysicist, pretty sure I can get a job by wandering out and asking. Geologists come and go, but when there's a boom on, there's a massive shortage. There's never enough people. And the last thing, the pay is good. I'll be fair, the dentists usually win, but geology, earth sciences usually comes in second or third in regards to pay. So during the boom two years ago, at least 2 of my students graduated and started on salaries that were the same as mine here at the university. That was in the middle of a boom. So that's why. And then, what's geology? If you wandered in, what's it say? It says geology is the study of the Earth as a whole, its origin, structure, composition and history. Covers everything. Geology goes from the beginning of the Earth right through to now. So if you're interested in understanding why there's a mountain range, geology is the one of the possible solutions. If you're interested in understanding why you have sedimentary basin just here, why you have a river channel draining off there, geology can provide that. If you're interested in the origin of life, geology assists in figuring that type of thing out. Geophysics says exactly the same thing, except it has the word physics in there. The main difference is geophysicists use physics to understand the Earth. The little example I'll give is I study magnetic fields, but I don't study today's magnetic field. I study the magnetic field from 250 million years ago to figure out what's going on and where the continents are moving. I have students who are currently working in, I'll say Vietnam, but it could be Laos, I can't remember what he said, and he's been doing it for a couple of years, just looking for unexploded ordnance, because it's obviously a country where there's a lot of bombs being dropped. And that's what he's been doing routinely now for a couple of years. He finds them and someone from the military comes and disposes of them. So geophysics just uses all the techniques of physics to look at the Earth from the tiny scale all the way through to the big scale. So why do we have earthquakes? Why did this earthquake occur wherever it did? All right, so reasons. Science, so this is me. This is why I went off to do geophysics. Science, the need to understand. Geophysics, geology are good subjects because you don't have the full data. The Earth, you can walk over the top, you can drill a few holes in it, but it's a big beast, and so you don't have the full data. So there's a lot to figure out. Exploration. Now, when I went to university, I had visions of going off and finding ore bodies. I didn't quite get there. I got sidetracked by other things. But the need to find is quite good. As our petroleum reserves reduce, as our ore bodies get less and less, those sciences are the ones that are going to find them. They'll be deeper and smaller and harder to look at. Toys, you can tell because I brought a toy in. And geophysics, quite a lot. You're looking at the physics of things, and so you need equipment to actually measure it. Now, I'll be fair, the physicists have the biggest and most expensive toys, but the geophysicists just have ones that they can actually take out in the bush with them or connect to vessels, and I'll look at some of those later. The urge to travel is strong. Now, I'm a researcher who spends a lot of time either in Antarctica or on the east coast of Australia, but a number of colleagues have been from various places in Pakistan when you could get there without being shot, all the way through to the back of Manly to work in. So if you want to travel, you can. As I said, I have a student who's never left the office in Perth. He works for a petroleum company. His job is to process data. Doesn't care. So it goes all the way. And money. It's a well-paid profession because in some cases you're out in the middle of nowhere, in other cases it's really hard and they need talented people to actually do that. So it's always well paid as a geophysicist or a geologist. So jobs. Mineral exploration was the one I always think of first. If you're going to graduate as a geologist, geophysicist, the odds are you're going to look for ore bodies or petroleum reserves or something like that. Oil, gas, as it gets harder and harder, and while we still need petroleum, geophysics, geology is definitely vital to actually do that. Groundwater, to some extent in Australia, but in Africa, a lot of people use the geophysics to understand where the groundwater is, to get fresh water, etc. And so it gets used a lot. Engineering, these days if you build a freeway anywhere or a highway, you have to do geophysics in front, so the engineers know exactly how to plan for all the movement of material, etc. Any tunnel, any buildings, those types of things will run geophysics, and to a lesser extent geology. So you certainly get a run there. And I have a number of colleagues in the industry who they did the geophysics for the salinity plant in Sydney, and they basically figured out where the bedrock was before the engineers came in to dig it up and move things. Pretty picture. This is not me. I wasn't allowed in one of those tunnels, but this is one of the geophysics colleagues taking a photo because they were doing various geophysical tests on the constructed table, and then this is a random shot of a large truck. Love it. All right, environmental aspects get a run. Now, geophysics is an excellent technique for looking for environmental problems because you don't have to dig up, you don't have to drill holes, and so you can actually image things by walking over it. And so it gets a run quite a lot. So in other words, I've got an old petrol station, I've got old tanks, someone left a tad too much fuel in it, it's starting to leak out. Where exactly is it leaking? Geophysics is one of the techniques they'll use to actually find where it's going, and then they'll do the remedial work from there. So it'll get used quite a lot in environmental things. Unexploded bombs, it's a mainstay. By bombs, it's stuff fired out of cannons rather than mines designed to injure, but geophysics is one of the techniques, and everyone's now seen the little drones that hover above everything, not the big military ones, but the small ones. Techniques will come where that'll become more and more frequent. And archaeology, excellent technique. I have a perfectly manicured lawn on my estate, and I think there's a Roman villa under it. I'm not going to dig it up. I'm going to run a bit of geophysics over it and have a look first before I invite someone in to dig it up. So they certainly get a run. This is me. I ended up doing research because I had burning ambition to understand things. I still have the same burning ambition, I just haven't got anywhere with it. But there's me undertaking a gravity survey, so I'm measuring the Earth's gravity field over an ice sheet to determine just what was underneath the ice sheet. So this is me being very dedicated taking a reading. Geologists, same thing. They work for exploration companies, mining companies, oil and gas, environmental engineering, government surveys, universities. So the two are the same. The main difference I'd say is geophysicists in the environmental world, there's much higher demand for them because their techniques are non-intrusive. You can do a whole bunch of surveys without having to touch the ground, which is quite important in a lot of cases. Oh, there's me. All right. Other things, we have a couple of students who are doing law science, but it's law geology. Why? Because they're going to end up in the part of the law world where people say, oh, I need $5 million to start a company to drill holes because I'm going to find gold just there. And the lawyers get involved, they have the geological background to actually see what's going on, whether they believe it. I had an honours student who did a mathematical geophysics project, and we were looking forward to him working for an exploration company, and one of the banks grabbed him because he had enough geophysical knowledge to know that all the the items that come in wanting many millions of dollars, whether they were sound or not. And then teaching. A number of people just go straight into teaching. They've got a geophysics or a geology degree and they go off and teach science. If you've got the geophysics, you might teach a bit of maths and physics, etc. It's more to your style, etc. Now, none of these are ever up to date and they're always biased, but this says money earned, and this particular year it says optometry, but usually in here, at number 2 would be geology and geophysics, especially geophysics. It's quite a good salary. If there's a boom on, I've certainly had particular years where the companies offer jobs to the third year students before they complete. I've had other years where the honours students who've done their 4-year degree are just doing casual work, they haven't got permanent jobs. But if you start on a reasonably good salary. There's not many of you. It's a job that you can be out in the bush, so it requires a certain amount of recompense. This is one of our PhD students sampling in somewhere in the hills of New Zealand. All right, now, she was someone who went away, worked in a different field, came back and started to do a PhD. So that's the other option. People who have a burning ambition to come off and do PhDs, etc. I think I've emphasised enough how great it is. This is the part I like. This is a photo that one of my students took somewhere in a gully. I'm going to say the Blue Mountains, but if someone says I've been there and it's in the Northern Territory, I won't doubt you. You get into very exotic locations, and many a time I've sat in the middle of nowhere and said, you could never get here as a tourist, while I've been doing a survey where I've just hiked for 4 kilometres to take a reading at that exact point because I think it's useful to do, and the bush is superb. Now, I haven't ventured out of Australia too much. Antarctica doesn't really count because it's all white and icy, but a lot of students go to very exotic locations to do surveys. I have an ex-PhD student who's in PNG at the moment on a petroleum product, and he sends me the occasional photo of him in a helicopter in some weird and strange valley. All right, so that's the ad. So if you want to get out, you want to be reasonably paid and you want good problems to think about, geology and geophysics is the go. Now I'll focus a little on what I call the nitty-gritty. You can kind of do Bachelor of Science and the Bachelor of Marine Science. Most people will do the Bachelor of Science and they'll have different majors. So a major is a coherent bit of study where if you do that, you can call yourself a geologist, or you can call yourself a geophysicist, or you can call yourself an environmental geologist. So you have enough to get yourself a job in that particular field. Now, this is the nitty-gritty. When you meander around the campus grounds and you chat with various people on the booths, they'll hand you green bits of paper if you're in the Faculty of Science, and they'll talk about majors and you'll go, that's great, I've barely come to grips with HSC 101. It says completion of a planet unit. A planet unit is something that's in a table of planet units, but you get it from the name. It's something looking at the planet. So our particular planet unit is called the planet Earth, and it's aimed at anyone in the university can do it. And so people from the arts faculty can do it, people from the science faculty can do it. The second one up there says it's a people unit, more on the art side of things. My favourite one is ancient history 101 type thing. Anyone can do it, so people from the science faculty can do it, people from the arts faculty can do it. And these are designed to broaden your horizons in fields that you haven't thought about before. And then it says completion of a major. And the major is a very listed specific set of units. So units are just a course you do that classify you as a geologist, a geophysicist, a biologist, or something like that. And then comes the very fine print. It says you've got to do 69 credit points, and you're going, what exactly is a credit point? And the easiest way to say that is all units are 3 credit points, 3, and that's about 130 hours of work. Either you listening to a lecture, you doing a prac or a tute, you writing at 4:30 in the morning some assignment that's due at 9 o'clock that morning, that type of thing. They're after about 130 hours of work, and you normally do 24 credit points or 8 units in a year. Right, so Macquarie is fairly unique. It says do 69. They give you one semester where you don't have to do four units. And then the fine print gets even better. It says at 200 level or above is 39. In other words, yeah, you can come to uni and do as many 100 level first year units as you wish, but you've got to pay some attention to your later years. And then the very last thing says you've got to do 18 at 300 level, which is 6 units at the final level or more. Nothing stops you doing more. So that's the way the degree works. So you don't do 24, 24, 24. You can have a more on the 100 level because you might try different things that interest you and very focus in on your particular science towards the end. So all the degrees for science will say that, except you'll do a different major. Now, what did Mark say next? All right. Do a set of units, do a capstone unit. Capstone unit is always something that brings it all together. So in my case, my capstone unit is we go out to an old mine site, we investigate the contamination around the mine site, and then the students write a great big report on where they think the contamination is. So it brings all their geophysical skills together to solve a very distinct problem. Now, this is one of those things where the academic says, this is for later reading, but this is the major in geophysics to give you a feel for what's going on. So at 100 level, it says there's a few units you can do, you have to do. At 200 level, there's a couple of units you have to do. At 300 level, there's one unit called the capstone, which is the one we're off to the mine site next week. And then another one that's compulsory, and then some choices. So that's what a major will usually say, that type of thing. And so when you get a brochure from someone saying biodiversity or something, that's what they'll do to you. This is geology. I'll ignore that because I'm not a geologist. Right. So at this point, I thought pretty pictures or toys. Now, a good geophysicist likes toys. An academic will test this in his office first, and it'll fail in the classroom. That happens all the time. Everyone knows what it is. It's a metal detector, and a good academic should have brought a coin with him. Yes. Now it'll beep because it hates being in a room. It's supposed to be out in the middle of nowhere. But it's a geophysical technique. I have a coin. That's a loop of wire. You pump a current in the loop of wire and it makes a tiny magnetic field. You pump the current in the other way and the magnetic field swaps. And so it spends all day swapping, and what happens is if it sees something metallic, the metallic thing generates its own tiny magnetic field and this thing beeps at us. All right, so this is a tiny thing. It works about that depth. And you've seen everyone on a beach with this. They're obviously finding the same coin on a beach. And they're not expecting to find it down 100 metres. They're expecting to find it here. Enough noise. So that is called an electromagnetic technique. You can put the same loop of wire on a giant plane, fly it 80 metres above the ground and look for an ore body 300 metres beneath the surface of the ground using exactly the same response. The ore body generates its own tiny magnetic field and the system detects it. So that's what geophysics is about. Now, this technique's fine. In Australia you find coins. In England you find Roman artefacts. That's about the main difference. All right, I'll ask, are there any questions first before I proceed through pretty pictures from my life as a geophysicist?
Yeah, as far as the geographies are concerned for a geophysicist, what's the ratio of city jobs to country jobs in Australia?
If you're in the petroleum industry, a lot more office type jobs, because once you've acquired the data, it takes an awful long time to process it. In the minerals industry, there's more actually out and about type jobs. And then it depends on who you are. Some people get jobs where they just acquire data, so they're just out on the field crews. Others like me, so if I went into industry, my job would be to go out occasionally, but to interpret the data that someone else has acquired. So the ratio I'd say is in the petroleum industry would be 70-30, and in the minerals industry 50-50. In the environmental industry, most people are based in the big cities, and they go out for small periods, so they're based here rather than living somewhere else.
And are there plenty of jobs around at the moment?
It varies. So at the moment, full-time jobs, it's much harder to to get one as a graduate, but a lot of the graduates get jobs as casuals. If you're not willing to go to Perth, it's much harder on the eastern seaboard. In the middle of the boom, they'd fly you in and out of Sydney, but now they want you to move over there. It's cyclic. Geophysicists have a distinct advantage over geologists, is the environmental industry never really changes. It always wants to solve things, and so if you have a job with those, you don't tend to get culled as much as in the minerals industry, where they can stop whole programs like that. But then no one really gets unemployed for too long. I still have colleagues who are 70 who work as consultants, and they still work. So there's still a need, there's no distinct shortage.
So most of them would be freelance, aren't they?
The older ones. The younger ones, it's very rare that people set up their companies and things like that. They're usually working for someone else. Yeah. Or the big companies. The big companies will hire graduates on a fairly regular basis, but they're obviously picking the cream of the audience. Yeah. All right.
Can you do combined degrees?
Yes, it's very common to do double majors, so a double major in geology and geophysics, which doubles your capabilities. So you're a geologist who knows an awful lot about geophysics, or you're a geophysicist who knows an awful lot about geology.
So what about doing a complete combined degree, like where you've got your Bachelor of Science with your geophysicist stuff, is that right? And then like a Bachelor of Arts with archaeology or a language or something?
Yep, you can enrol and do a double degree, yep, where you do, so at the moment it's 69, I think you do 96 or something like that, over 4 years.
It's available with your course?
Yes, so the double degree, you're just doing a major in science and a major in arts, but you don't have to do the full 2 lots of 69. Yep. A lot of people will do, in arts, they may well do some of the science majors, because arts just says do something. And there's only a whole bunch of science ones classified. I don't know if geophysics does though. Yeah. All right, this is my last chance. This is called the Chaos Glacier, and I was in a helicopter flying over it to my field site where I was doing the gravity regions. They wouldn't allow us to land there for obvious reasons. On an ice shelf, there were 6 of us on an ice shelf. The nearest safety was 3.5 hours away by helicopter. If the snow got up where we were, helicopters wouldn't come to us, and if it blew where the base was, helicopters wouldn't leave the base. So it was fairly isolated. And we were out there, and our job was to find out how thick the ice shelf was, because it had water underneath. And we got round on skidoos, and it was most enjoyable. There's my PhD student letting off explosives somewhere out of view. The same year, I had an honours student, and he was looking at that, some lake somewhere in the Sydney water catchment area. And the reason was, and it's quite controversial at the moment, is they were coal mining underneath various areas there, and he looked at a lake that had water, even I can see the water there, and one that didn't, and he was looking to see the geophysics to see what the difference was between the 2 areas. So that was my range of students that year. I had someone looking at ice in Antarctica, and someone looking at the lake in the Sydney catchment area. This one hadn't been mined under. This is a volcano, because it's a nice picture of a volcano. But we have a number of staff members who look at volcanic rocks. This is just in New Zealand, and it's a tourist shot by Mark. But a number of people look at the volcanic islands, study the geology and things like that. So that's one of the other aspects you can actually go with. This is geophysicists and their toys. The yellow thing, I'll say thing, is a bigger version of the beast there. And if I go to the next one, no, come on. All right, here is the ad. They were using it there to actually find out how deep the Sydney Harbour was. The device finds conductors, so it finds metal, but water's a conductor, everyone kind of knows that. So therefore, it's easy to say conductor sitting on rock. How much conductor have I got? I know it's there, I know the properties of water. And so you run around with your boom, which means you don't have to do any soundings, and you can actually do the whole bay quite effectively and get an image of the the bathymetry of the bay. And it's one of the other techniques they use. The military use it quite a lot on figuring out whether their ships will go in particular areas. Now I'll move up through it. The tiny white thing at the end is a magnetometer. It means there's tiny changes in the Earth's magnetic field. Unexploded ordnance is a little bit of metal. Earth's magnetic field is one value. You go to the tiny bit of metal, it's stronger, you get a bump, and you detect the presence of the unexploded ordnance. Click. This is what happens when you do geophysics with me. You stand round staring at the campus grounds. This is the class doing an electrical survey on the campus grounds, looking at what makes up the soil on the campus grounds. There's different soil types. And importantly, how far it is to the rock, if you can't actually figure that out from that, just using an electrical technique. So the little wires and the little stakes you can see, just where the mouse is, you just pump current into the ground and see what happens to the ground as a response. We're looking on campus at all of 10 metres, but you can imagine doing that in Africa at half a kilometre spacing and looking at water aquifers and things like that. It's a pretty standard type technique. All right, one more, two more. Here we go, last one. This is a ship for doing seismic works, and this was given to me by one of my students who was working on the vessel. Where it says air guns, they fire compressed air into the ocean, and that sends out a seismic wave. And where it says streamer, they record the response of the wave back. So the wave goes down, goes into the ground underneath, goes through all the rocks, and eventually reflects off something, oil or something, comes back, and they actually map the Earth that way. And you can see why petroleum surveys are done mostly on ocean these days, is because you can do an awful lot of activity.